Okay, in summary, what do I expect you to be able to do or know for the test? And this list is not exhaustive. I may vary from this, but these are the things that I see as the important points of this chapter or unit. And I expect you to create a one-page wonder so you have everything that you need in one spot so that when you start your test, you can finish. So it can be one page, front and back. I'm not going to collect it. Well, I'm going to collect it, but I don't really care how long it is. It should be organized, it should be colorful, and it should be helpful for you. I don't have to understand it. However, if I see an error, I will let you know. So you should know your vocabulary. You should be able to identify oxidation and reduction reactions, half reactions. So if you have an equation, you should be able to pull out from that. If copper goes to copper 2+, it means it lost electrons, so that's an oxidation reaction. You should be able to assign oxidation numbers, even in complex ions. You should be able to balance redox equations, and the good news is I probably won't give you any basic ones, I'll just give you acidic ones. You should be able to identify the anode and the cathode in a cell. You should be able to write the standard cell notation and be able to write in a reaction from a cell notation. So if you're given a reaction, you should be able to write the cell notation. If you're given the cell notation, you should be able to write the reaction. You should be able to identify as well where the anode and cathode are in that cell notation. And then you should also be able to identify which electrode will increase in mass and which one will decrease in mass. And I know I'm talking quickly, so feel free to stop, write something down, rewind, and listen again. You should understand what the function of the salt bridge is. Why do we need it? Given a table of reduction potentials, you should be able to calculate the cell potential of a galvanic cell. You should be able to use the Nernst equation, and I gave you that triangle. I think that would be a good thing to have on my review sheet, because I will be asking you to calculate cell potential, delta G, and K from something else. You should be able to calculate non-standard cell potential, so if the molarity is greater or less than 1 molar, you should be able to calculate that. You should understand how an electrolytic cell is both the same and different from a galvanic cell. What do I mean by that? Oxidation still occurs at the anode. Reduction still occurs at the cathode. However, and the electron flows the same direction, but what happens in electrolytic cells, we have to supply that energy. In a galvanic cell, we're getting out that energy. And you should be able to, using electrolysis, you should be able to calculate the time necessary to electroplate a particular mass, or how much mass will be deposited after a certain amount of time. And so you might want to have an example of those two questions written out for yourself. Please ask if you have any questions or you need some more information about any of these topics I've gone over. And also, if you have trouble with any of the worksheets, let me know and I will make an additional video or two. Thanks.